Problem 92, we see the velocity graph. Figure shows the velocity, so we can label that. Velocity at t. Okay. In meters per second of body moving along a coordinate line. Sketch the graph of the acceleration where defined. Well, we know that in between 0 and 2, the slope, let me just do this. Let's do this, let's just mark down here what the slopes are at each point along the way. Slope between between 0 and 2 is 0. The slope between t equals 2 and t equals 4 would be down 4 and over 1. So slope is negative 4 here. In this section here between t equals 4 and t equals 6, we see that the slope is up 2 and over 2, so slope is 1. And again, between t equals 6 and t equals 7, we see that the slope is 0. Okay? And all we're going to do here for the acceleration is just graph the slopes. Okay, so we see also now we have a little bit more knowledge now than we did on the last test. We know that the derivative at sharp corners is non-existent. Okay, so the derivative does not exist anywhere we see a sharp corner. The derivative from the right does exist, and so that's why we have a closed circle here at 0, 0, but we have an open circle right there at 2, 0. The slope is 0 and the derivative doesn't exist when t is 2. And then between t equals 0, 8, negative 3, 3. Interesting, negative 3, 3 is the y. We have down 4 and over 1. So let's change this. We need to change. I'm sorry, I'm pausing here because I'm looking at my units here. I don't want negative 3 to 3, I want negative 6 to 6. So we want to make each of these little tick marks along the y-axis equal to 2. So we can put the whole graph within the box. Anyway, when t is equal to 2, we jump right down here to an acceleration of negative 4, and it stays at negative 4 until we get to t equals 4. And then from t equals 4 to t equals 6, we see we have an acceleration of 1, and so we're going to put that guy right there. It's tough to fit all that in there. And then again, between t equals 6 and t equals 7, we have an acceleration of 0. And there you go. That's the graph of the acceleration. On what interval is the particle moving at a constant speed? Well, since this is the graph of the velocity remains the same between t equals 0 and t equals 2, and also t equals 6 to t equals 7. So if the velocity is remaining the same, then the speed must be remaining the same. So therefore, between t equals 0 and t equals 2, and also between t equals 6 and t equals 7. 92C is asking us for when is the particle moving to the left. Well, it's moving to the left when the velocity is less than 0. Remember, the velocity is less than 0 when the velocity graph is under the t-axis. Okay, and so it's under the t-axis from t equals 3 to t equals 7. Okay, so from t equals 3 to t equals 7. Good stuff to know. I'm hesitating here on whether I should do number 94. I don't know if that's, yeah, I guess that is 94 up there. You know, I'm going to do that in the next video. I want to show the graph and annotate the graph as well. But we will do number 95. We have the graph of the derivative shown here. Use the graph of the derivative to answer the following question about f. Which is larger, f of 3 or f of 6? Well, this is a really neat question. It'd be great if you could understand every part of this. It'll help you appreciate and get an understanding for the graphs of f and f prime and even f double prime and how they're related. Well, we can see, I'm going to try to go ahead and construct a graph of f. Okay, again, we don't know how high or low f goes because we can't go backward unless we have an initial condition. You don't have to worry about that part. What you do need to concern yourself with is just using the information here from the graph of f prime. So the graph of f prime, I'm going to show you here. I'm shading this in. It doesn't look very good on the screen, but nevertheless, shading it in underneath hold on. Yeah, I'm going to try to draw the graph of f of x, given information about f prime. And f prime, we can see underneath the x-axis, this is when f prime is negative. Okay? Well, f prime negative means that between t equals 0, or x equals 0 and x equals 3, that means f is decreasing. Okay? Notice here we have f prime equaling 0 at x equals 3. So f prime equals 0. That means a horizontal tangent line. Well, if we have a horizontal tangent line, I don't care where you put the horizontal tangent line. I don't care where you put f of 3. It doesn't matter. Okay? What does matter is that you can see that in between x equals 3 and x equals 6, we have right up here, let me put this in green, see if I can get this looking better. In green, and I don't know if you can see that or not, but nevertheless, above the x-axis, we see that f prime is positive. And if f prime is positive until we get to x equals 6, that means that f is increasing. Okay? So if f is increasing, and then we get to, again, another horizontal tangent line when f prime is equal to 0, because f prime is equal to 0 here and here, then and then f is again decreasing to the right of 6, we can see that because f prime is increasing, f prime is positive between x equals 3 and x equals 6, f is increasing from 3 to 6, so therefore f of 6 must be larger. F of 6 must be the larger of the two, and the main reason is because since f prime is positive on the interval from 3 to 6, that concludes, we get to conclude that f is increasing. So, and f increasing on that interval means that to get from f of 3 to f of 6, you have to go up. Therefore, f of 6 is bigger. That's it.